Hello, this is the last fourth part of the chapter 2.1, and it's about the matrix transposition. And you're probably already tired of the chapter 2.1. It's rather long, it's a lot of definition, but hold on to the last part. It's actually fun. Matrix transposition is easy to do, and I don't know, from my experience, students are enjoying doing this. Okay, so what is the transposition? It's a really fun operation. You just take the rows of the matrix and make it a column, and that's it. For example, let's just see our matrix A, which has a 4 arbitrary entry. It's 2 by 2 matrix, and I'll just color code the rows just to make our things easier. So what would be a transposed matrix A? And by the way, the transposition is denoted by the up script, higher index script with a capital T, AT. So, and okay, let's try the transposed matrix A. So we just take a first row and make it a column. And then we take a second row and also make it a column. And that's it. And that's a transposed matrix. And you can do any matrix transposition of any matrix size pretty easily. And transposition is very, very useful operation. We can use it a lot. And there is several properties of the transposition operation. For example, transposition of transposed matrices is equal matrix itself. The sum of the two matrices transposed will be the sum of transposed matrices. If we are transposing matrix multiplied by a scalar or number r, we can actually transpose the matrix itself and then multiply by the scalar. And finally, the product, transposed product of two matrices. We know that the multiplication is a kind of weird operation, so we have to be very careful. But with transposition, it's actually pretty nice because transposed matrix of the product is actually equal to the product of two transposed matrices. We just need to change the order of the matrices. So here on the left-hand side, we use product A to B. So on the right-hand side, we actually B goes first and T goes second. And we know for multiplication order matters. And all of these four properties can be easily derived if we use the arbitrary matrix A and B's. And I strongly recommend you to read through the chapter and work through a derivation. I'll do just the one property here just to show the example. For example, let's look at the first property, the transposition of transposed matrices. And let's just try to calculate what's happened if we apply it to the arbitrary matrix A. Okay, and again, I'm color coding the rows. So let's just do two transposition. Let's start from the inner one and see what's happened. So again, we took the inner matrix and replaced our rows with the columns. So that's really nice. So now let's just do it again. And we are again replace the rows with the columns. And as a result, we get exactly the same original matrix as we started that with. So again, double transposition equal the matrix itself. Okay, so now go ahead, read chapter 2.1 and work through more examples and try to derive all of these four properties.